Let's go ahead and take a look at a tool called Memory Monitor. Memory Monitor is a tool that can show you how your application is using memory over time. Let's go ahead and start it. As with other demos, if you want to follow along, make sure you start Android Studio, connect the physical device, and enable debugging, and then make sure your Sunshine application is in the forefront. So if we want to start Memory Monitor, we can do so through the menu, like so. We're going to go to Tools, Android, Memory Monitor, or if you have an icon here down at the right, you can go ahead and click that. So let's do that. Okay, so the tool opens as a tab at the bottom right of your Android Studio window. And if it finds your application, it's going to immediately start recording memory usage right from your app, just like you should be seeing right about here. At the top left of your Memory Monitor window, you will be able to toggle your currently connected devices. And on the right, you can select the application you want to monitor. The stacked graph that takes up most of the window shows the total memory available to your application. The amount of memory that your application is currently using is shown in dark blue. And the free memory or unallocated memory that's available to your application is shown in light blue or light gray. The graph updates continuously to show you changes in memory usage, and it shows you how much memory the app has available to it over time. Now, in a world where your app isn't doing much of anything, you should see a flat graph like this one. From a performance perspective, this is actually an ideal scenario. But as your application allocates and frees memory, you'll see that the allocated amount changes in your graph. And if your app suddenly needs a lot more memory, the overall memory allocated for your app will also increase, represented by this box here. Because if it didn't, your app would run out of memory and essentially crash. Now, anytime you see the allocated memory drop by a significant amount, like here, that's a pretty good signal that the garbage collection event has occurred. Now, in this example, the garbage collection looks pretty healthy. On the other hand, in this graph, it looks like there might be some problems. You see, the app allocates a lot of memory within a short time, then frees that memory almost immediately, creating these narrow, skinny spikes, and it does it over and over. This means that your app is spending a lot of time garbage collecting, and the more time you spend doing GCs, the less time you have to do other stuff, like rendering or streaming audio. So let's see what this looks like live. Okay, so here we are with Memory Monitor running on Sunshine. Now once we start tapping on a day, and then looking at the detail view, and then say tap the back button, or say we do this a few times, we're going to see that our memory starts to fill up, just like around here. And say we were to go ahead and change the zip code a few times, just to get some new data, and go back and check out some more detailed weather information. Cool, looks like it's going to be clear on Wednesday. Ooh, a little rain on Friday. So gradually, we're seeing how memory is filling up. And eventually, it'll actually grow until we actually have no more free memory left. If we keep going, at this point, a garbage collection event will be triggered to free up a chunk of memory. You can see this drop happen right here. Now remember, this does not free up all the memory because Android's memory management system is generational in nature. In our nifty tool, we can actually force individual garbage collection events. There's this garbage truck tool here on the top left of the Memory Monitor. If you press it, it's going to go ahead and trigger an individual garbage collection. Notice what's happening here on the right of the graph. Now we can go ahead and actually press it a few times. And if you do that a few more times, you can free all the freeable memory, like so. And this seems to be back to our original state. Okay, so next we're going to take a look at memory leaks and the Heap Viewer tool. And finally, we'll use all of these together to find and fix memory leaks in some real code.